Okay. Okay. Is it the screen is visible to all?
Yes, sir.
Okay. In the previous lecture, we seen that the D'Alembert solution of the one-dimensional wave equation when the vibration of the string is infinite length, infinite. Okay. That is, the both the ends of the endpoints are not fixed. Okay. So in this lecture, we will see the case number 2 when the one point is fixed and another point is not. Okay, vibration of a semi-infinite string. Okay, so this is the solution of one-dimensional wave equation when the string is of length infinite length. Okay, what is the solution? This one. Y of xt is equal to 1 upon 2 into f of x plus ct plus f of x minus ct plus 1 upon 2 c. Okay, into integration of x minus ct to x plus ct g of s ds. Now, this case number second, case number 2 is to vibration of a semi-infinite string. Vibration of a semi-infinite string. Okay, what is the meaning of this sentence? The one end point is fixed. The one end point of the string is fixed. One end point is fixed. Okay, म्हणजे तुमची स्ट्रिंग कशी असेल एका ठिकाणी तुमची फिक्स असेल आणि तुमची स्ट्रिंग अशी व्हायब्रेट होत असेल. ओके, आधीच्या केसमध्ये काय होते तुमची दोन्ही एंड पॉइंट्स कसे होते नॉट फिक्स्ड. ओके, now look at this question. Obtain the D'Alembert solution of the one-dimensional wave equation. Obtain the D'Alembert's solution of the one-dimensional wave equation. Solution of the one-dimensional wave equation, which describes the vibration of a semi-infinite string. The vibration of semi-infinite string. Okay, now look at solution now. By previous case, we have the vibration of a string. The solution of vibration of a string is given by y of x is equal to this one. Okay, this is the solution of vibration of a infinite string. Okay, using this equation, we have to solve for semi-infinite string. Okay, look at the solution now. We know that vibration of a string. We know that vibration of a string is described by the second order partial differential equation. Okay, second order partial differential equation is given by one-dimensional wave equation is given by y double x is equal to 1 upon c square into y double t. Okay, now here the x running from 0 to infinity. Okay, in the previous case, x running from minus infinity to infinity. Okay, why? Because both the ends are not fixed. But here the one point is fixed. Okay, that's why here x is running from 0 to infinity. Okay, give it as in question number 1. Now here the x and t are the independent variables and y is dependent variable on xt. Okay, where y of xt is the deflection of the string at any point x and any point t. At any point x and any time t. Okay, so y of x is the solution of this differential equation. Okay, where x is the deflection of the string at any point, deflection of the string at any point, and t is time interval. Time. Okay. Now, since the string is semi-finite, okay, and hence one end of the string is what fixed here. Okay, since look at it, since the string is semi-finite, string is semi-finite, so semi-infinite, all semi-finite as well, and hence the one endpoint of the string, one end point of the string that is x is equal to 0. The deflection की तरह से starting point like x is equal to 0 kept fixed. Okay, kept fixed for all time t. Okay, प्रत्येक time all time t, for all time t, the one end point that is fixed. Okay, that is x is equal to 0. Now, if u of x, okay, u of x is the initial deflection. Okay, initial deflection of the string. Okay, p of x is the initial deflection of the string, and v of x is initial velocity. Initial velocity of the string. Okay, we assume that u of x is the initial deflection and v of x is the initial velocity of the string. Okay, here look at here. Y of x is the solution of this differential equation, and these are the two initial conditions. So it means these initial equations, that is this solution, it satisfies this initial condition u of x and v of x. Okay, then the function, y is the function of x and t is required to satisfy, okay, to satisfy the initial condition. Okay, now y is the function of x and t. If t is equal to 0, what it gives, that is initial deflection. At t is equal to 0 काय मिळेल मला, initial deflection. Okay, that is y at x0 is equal to initial deflection साठी आपण हे केलंय, denote u of x. Okay, give it as an equation number 2. So this is the initial deflection. In the bracket right down, this gives the initial deflection of the string. Initial deflection of the string. Okay, now what is yt of x0? This is the initial velocity. Differentiate y with respect to t. Okay, hence the dx by dt we have velocity. That's why here yt of x0 is nothing but initial velocity, and it is given by v of x at time t is equal to 0. It means it is initial velocity. Okay, where x is here greater than 0. Okay, so give it as an equation number third. And write down in the bracket this gives y, this gives the initial velocity of the string. Initial velocity of the string. Okay, any doubt up to here? Which one doubt ahead?
No, sir.
Okay. Now the deflection. Look at here. Two more conditions are there. Initial condition, boundary conditions. Now the deflection of the string. Okay, y of xt also satisfies. Which condition also satisfies the boundary condition? The boundary condition. Which one? Look at it. Y of 0t is equal to 0 at point 0, that is x is equal to 0. What is the deflection of the string? 0. Okay, so this is the boundary condition. Also y of 0 and t. x म्हणजे काय तुमच्या इकडे एनी पॉइंट. ओके, at x is equal to 0 ला तुमचा काय होईल? इनिशियल डिफ्लेक्शन काय होईल तुमचा? 0. Okay, give it as equation number 4. Now this shows that, right on in the bracket, this shows that there is no deflection of the string at fixed point x is equal to 0. There is no deflection. There is no deflection of the string at fixed point. At fixed point x is equal to 0. Okay. Now one more condition is there, and yt of 0t. Okay, initial velocity at point 0. Sorry, velocity at point 0. X is equal to 0. It is also 0. Okay, at x is equal to 0 ला काय असेल तुमचा इनिशियल वेलोसिटी 0 असेल. डिफ्लेक्शनच नाहीये तुमचा इथे, तर मग वेलोसिटी काय त्याला डिफरन्शिएट टी विथ रिस्पेक्ट टू टी केल्यानंतर काय येईल? हा 0 च येईल. ओके, so this gives, write down in the bracket again, this gives, that is, this shows that, or this gives the velocity of the string at fixed point, of the string at fixed point. Okay, that is x is equal to 0. It's 0. Okay, now look at here, equation 2, 3, 4, and 5. These are the initial and boundary condition. Okay, whatever be the solution of that partial differential equation, second order partial differential equation. Okay, it satisfies these 2 to 5. It चारही condition ते काय करायला पाहिजे? Satisfy करायलाच पाहिजे. Okay, now our aim to find the solution of the equation 1, that is the differential equation 1. Okay, this is the differential equation. So our aim is to find the differential solution of this differential equation satisfying all the 4 conditions. Okay, initial and boundary conditions. Okay, so right now, so our aim to find the solution of equation 1, that is y of xt, satisfying, okay, satisfying initial and boundary condition. Initial and boundary condition. Okay, 2 to 2, 3, 4, 5. These are the 4 initial and boundary conditions. Okay, so we know that the D'Alembert equation, the D'Alembert solution of equation 1 in the previous case is given by, okay, for infinite string. We know that the D'Alembert solution of equation 1 is given by, okay, in the previous case we seen that what is the y of xt? Y of xt is equal to 1 upon 2 into bracket, okay, u of x minus ct plus u of x plus ct. Okay, तिथे इनिशियल तुमचा f of x होता, इनिशियल डिफ्लेक्शन इथे u आहे म्हणून u of x minus ct. Okay, plus 1 upon 2c integration x minus ct to x plus ct v of s ds. v of s म्हणजे काय तुमचा velocity आहे बरं का v म्हणजे. So this is the equation number 6. Okay, so this is the D'Alembert solution of equation 1 for infinite string, that is both the ends are not fixed. Okay, from case number 1. However, this solution cannot be used. This solution cannot be used. Why? Because this is the solution of infinite string. Okay, so this solution cannot be used for given initial value problem. Okay, initial value problem. What is the initial value problem? Cast the initial value problem. Differential equation, the initial condition दिलेला असतात तिथे. Okay, तुमच्याकडे equation 2 and equation 3. These are the initial conditions आहेत तुमच्याकडे. So, however, this solution cannot be used for the given initial value problem. Okay, because why? Okay, because q is the function of x minus ct has no meaning for the value of t greater than x by c. ओके, तुमच्या इथे स्ट्रिंग कसं आहे इकडे पहा. आता तुमचा 1 इन पॉइंट काय तुमचा फिक्स, म्हणजे स्ट्रिंग अशी व्हायब्रेट होते बघा. ओके, हा जो सोल्युशन आहे, दिस इज द सोल्युशन फॉर द इनफायनाइट स्ट्रिंग. ओके, बोथ द एंड्स आर नॉट फिक्स्ड. अशी तुमची इनिशियल स्ट्रिंग होते, स्ट्रिंग काय होते ते व्हायब्रेट होते. ओके, but here the u of xt has no meaning for the value of t greater than x by c. काय होईल t जर ग्रेटर दॅन x by c असेल तर काय होईल. ओके, इथे तुमचा केस कसा आहे, हा पॉइंट फिक्स्ड आहे इथे. ओके, वेट अ मिनिट. हा x हा तुमचा पॉइंट कसा आहे इथे फिक्स्ड आहे, असं एक पॉइंट फिक्स्ड आहे की जर t ग्रेटर दॅन x मायनस x अपॉन c असेल, put the value of t here x by c. ओके, हा ग्रेटर दॅन t आहे बघा, मग हा काय होईल x मायनस x पेक्षा मोठी क्वांटिटी येईल कुठे. ओके, मग हा काय येईल x काय होईल u of x इज नॉट डिफाइंड होईल, u of -1 मायनस x येईल ना तिथे. बट u of x काय तुमचा डिफ्लेक्शन, आणि डिफ्लेक्शन कधी x हा ग्रेटर दॅन 0 आहे. ओके, सो फॉर मायनस क्वांटिटी the u of x is not defined. ओके, डिफ्लेक्शन मायनस मध्ये नसणार आहे तुमचा, कारण की इथे 1 एंड पॉइंट इथे फिक्स. हा पुन्हा एकदा काय सांगतोय, if t is greater than x by c. ओके, t जर x by c पेक्षा ग्रेटर देणार असला. ओके, फॉर एक्झाम्पल t इज इक्वल टू x by c, काय होईल u of x minus c into x by c. हा कॅन्सल होईल आणि हा u of 0 येईल. ओके, आता हा t जर तुम्ही x by c पेक्षा जर मोठा व्हॅल्यू घेतला तर इथे काय येईल, यू ऑफ मायनस येईल ना काहीतरी, मायनस एक्स वगैरे येईल असं काही. Okay, but here the one end point of the string is fixed. That's why this has no meaning. U of x minus x is not defined. Okay. So u of x minus ct has no meaning. Okay. Write down in the bracket for x. Sorry. T is greater than x by c. Okay. This implies x minus ct is negative, that is less than 0. But u of x is defined. For all x greater than 0. All x greater than 0. Okay. Hence, u of x minus ct is not defined at that point. Okay, कोणत्या पॉइंटला, the t जर greater than x by c असेल तर. Okay. So therefore, we modify our semi-infinite string. त्यासाठी काय करावं लागेल, जो काय आपल्याला स्ट्रिंग आहे त्याला काय करावं, मॉडिफाय करावं लागेल. So we modify our semi-infinite string problem. Okay, string problem to an infinite string. Infinite string problem by extending the data as follows. Okay, काय करतो आपण एक्सटेंड ह्याला, because this solution we can't use for semi infinite string, म्हणून ह्याला काय करावं लागेल, मला आता मॉडिफाय करावं लागेल. कसं मॉडिफाय करतोय पहा, तो जो सोल्युशन होता तो काय होता, बोथ द एंड्स आर नॉट फिक्स, म्हणजे तुमची स्ट्रिंग अशी व्हायब्रेट होती, हो की नाही, अशी व्हायब्रेट होती. पण इथे काय तुमचा वन एंड फिक्स राहील. ओके, अशी स्ट्रिंग व्हायब्रेट होती. मग याला जर मी एक्सटेंड करायचं म्हटलं तर मला काय करावं लागेल, एक्स लेस दॅन 0 ला काय करावं लागेल, ह्या स्ट्रिंग अशी डिफाइन करावं लागेल, असा एक फंक्शन डिफाइन करावं लागेल जो अशी ही पण व्हायब्रेट होती. ओके, कशी होईल. So we modified our semi-infinite string, this one, okay, to an infinite string. त्याला मी infinite string मध्ये कसा डिफाइन हे करणार, असा एक फंक्शन डिफाइन करेल की तो हा इन्फाइनाइट होईल. Okay, infinite string होईल by extending the data as follows. Look at here. Our second order partial differential is ux is equal to 1 upon square into u dt. आता काय होईल, minus infinity, x running from minus infinity to infinity. Okay, आता infinity minus infinity to infinity झाला. हा. Okay, give it as an equation number 7. Subject to the condition. What are the condition? The subject u of x ला मला डिफाइन करावं लागेल. कॅपिटल u of x असा डिफाइन करतोय मी. ओके, तो u of x असेल दिलेला ओरिजिनल फंक्शन. ओके, इफ x is greater than or equal to 0, हा तुम्हाला दिलेलाच आहे गिवन डाटा. आणि इकडच्या मायनस इन्फिनिटीला मी हा काय करतोय, मी एक्सटेंड करतोय. ओके, that is minus u of minus x. Okay, if x is less than 0. ओके, एखादा साइन फंक्शन आहे तुमच्याकडे, समजा f of x is equal to sin x. ओके, असं साइन फंक्शन इवन आहे का ऑड फंक्शन, म्हणजेच काय, f of minus x is equal to sin of minus x, that is minus sin x. ओके, म्हणजे इथं काय येईल तुमच्या f of x काय sin x होतं ना, f of x काय sin x म्हणजे काय f of x म्हणजे हा sin of minus x म्हणजेच काय sin x हा मायनस इकडे sin x इज इक्वल टू मायनस sin of minus x असा डिफाइन केला. ओके, मग हा तुमचा sin x चा व्हॅल्यू कसा असणार इन्फायनाइट कडे असणार दोन्ही बाजू. ओके, त्याचप्रमाणे डिफाइन केलं. ओके, so subject to the condition u of x is equal to v of x if x is greater than or equal to 0 and for x is less than 0 we define the function like this minus u of minus x. Okay, just like sin x. Okay, any doubt? Okay, one end आपल्याकडे फिक्स होता, आपण त्याला इन्फायनाइट स्ट्रिंग मध्ये कन्वर्ट केलं बाय युजिंग this one u of x is equal to minus u of minus x. Okay, similarly for the v of x, give it as equation number 8. Wait a minute. Okay, to give it as an equation number 8. Okay, similarly for v of x, we define v of x, capital V of x is equal to small v of x if x is greater than or equal to 0 and minus of v of minus x if x is less than 0. Give it as an equation number 9. Okay, now from u and v, we can see that u and v are the odd functions. Okay, here capital U and capital V are odd functions. Okay, so we know that now. आता तुमचं काय झालं इन्फायनाइट स्ट्रिंग कसं झालं फायनाइट सेमी इन्फायनाइट हा इन्फायनाइट झाला. ओके, आता इथं पण काय करू शकतो हा सोल्युशन दिलेला सोल्युशन आहे y of x t. Okay, we can use this equation now. Okay, so we know that the D'Alembert solution of equation 7. Okay, that is the partial differential equation. This one. Okay, equation 7. Subject to the condition, subject to the initial and boundary, subject to the initial condition 8 and 9. Subject to condition 8 and 9. Okay, and v it's given by okay y of xt. Okay, for infinite string we have the solution 1 upon 2 into. Okay, आता small u of x नाही येणार, इथे काय येईल मग capital U of x minus ct plus capital U of x plus ct. Okay, plus 1 upon 2c integration from x minus ct to x plus ct. आता इथे small v का नाही, capital V of s ds. Okay, give it as an equation number 10. Okay, so this is the solution for the semi-infinite string. Okay, so we have to check that condition equation number 2, 3, 4 and 5 जे नाही ते हा इक्वेशन सॅटिस्फाय करतो का नाही हा चेक करायचा आपल्याला. ओके, now differentiate equation 10 with respect to t. Now first differentiate equation 10, that is the above equation, with respect to t. We get what we get, yt of xt is equal to 1 upon 2 into minus c into u dash of x minus ct plus c into u dash of x plus ct. Okay, plus dou by dou t of 1 upon 2c into integration x minus ct to x plus ct v of s ds. Okay, so yt of xt is equal to 1 upon 2. Okay, 1 upon 2 into minus c into u dash of x minus ct plus capital C into u dash of x plus ct. Okay, in the differential equation, in the integral equation मध्ये याचा फॉर्म्युला डो बाय डो टी ऑफ इंटिग्रेशन ह्या फंक्शनचा डेरिव्हेटिव्ह कसं काढतो आपण. Look at here, integration x minus ct to x plus ct डो बाय डो टी ऑफ आत गेल्यानंतर काय होईल v ऑफ एस ds. ओके, याचा डेरिव्हेटिव्ह काढतो प्लस काय करतो हा फंक्शन आहे तसा लिहितो. या फंक्शन मध्ये काय पडतो तो अप्पर लिमिट v ऑफ x प्लस ct इंटू डेरिव्हेटिव्ह ऑफ विथ रिस्पेक्ट टू t. ह्या अप्पर लिमिटचं काय करतो आपण डेरिव्हेटिव्ह. ओके, इंटिग्रल इक्वेशन मध्ये याचा फॉर्म्युला आहे. त्याचं नाव मला लक्षात नाही पण इंटिग्रल इक्वेशन शिकला तुम्ही. शिकला ना, उस्मा मॅडमने शिकवलं वाटतं. v of x minus ct. Okay, put the lower limit in this function v of x minus ct into d by dou t of lower limit x minus ct. Okay, so this is the value of dou by dou t of this function. Okay, now solve this one. Yt of xt is equal to 1 by 2. Okay, into minus c into u dash of x minus ct plus capital C into u dash of x plus ct. Okay, हा फंक्शन काय एस मध्ये आणि हा विथ रिस्पेक्ट टू टी आहे. सो व्हॅल्यू ऑफ दिस वन इज 0. ओके, द होल टर्म इज 0. हा त्याचा डेरिव्हेटिव्ह काही 0. व्हॉट विल रिमेन हियर देन 1/2c आहे ना. ओके, हा 1/2c 1/2c. ओके, into v of x plus ct. The derivative of this one with respect to is c minus c into, okay, minus minus हा काय होईल तुमच्या इथे प्लस होईल. ओके, मायनस c into म्हणजे मायनस मायनस हा प्लस होईल v of x minus ct. ओके, हा c काय होईल कॅन्सल होईल. So here remains yt of xt is equal to, okay, 1/2 into bracket minus c into u dash of x minus ct plus capital C into u dash of x plus ct plus 1/2 into v of capital V of x plus ct, okay, plus capital V of x minus ct. Okay, give it as an equation number 11. Okay, so this is the yt of xt. Now we will show that the equation 10 is also solution of equation 1. जर हा इक्वेशन 10 इक्वेशन 1 चा सोल्युशन असेल तर तो काय सॅटिस्फाय करायला पाहिजे इक्वेशन नंबर 2 3 4 5 that is initial and boundary condition. Okay, now we will show that equation 10 is also solution of equation 1. Okay, subject to condition equation 2 to equation 5. That is the equation 10 satisfies equation 2 to equation 5. Okay, that is 2 3 4 5. Okay, from equation 10 we have, from equation number 10, okay, we have, तुम्हाला सोल्युशन मिळालेलं आहे. आता फक्त काय करायचं इनिशियल कंडिशन सॅटिस्फाय करतो की नाही हा चेक करायचं. ओके, फ्रॉम इक्वेशन 10 वी हॅव ऍट t इज इक्वल टू 0. ओके, मला काय करायचं इक्वेशन 2 सॅटिस्फाय करतो की नाही पाहायचं. इक्वेशन 2 कुठे आहे, दॅट इज इक्वेशन नंबर 2. y ऑफ x0 इज इक्वल टू u ऑफ x हा यायला पाहिजे. ओके, येतो का मग काय करावं लागेल, त्या सोल्युशन इक्वेशन 10 मध्ये मला काय करावं लागेल, t इज इक्वल टू 0 पुटअप करायचं. ओके, and x is greater than 0. Put t is equal to 0 in equation 10. So what we get, x0, y of x0 is equal to, कुठे आहे तुमचं इक्वेशन 10, हा तुमचा इथे 0 येईल, हा काय येईल u of x, हा काय येईल u of x, कॅपिटल u of x 0 कुठला, हा काय होईल x to x होईल लिमिट. ओके, म्हणजे हा काय बोन टर्म्स 0 येईल. ओके, u of x 2 कॅपिटल u of x. ओके, हा 2 टू गेट कॅन्सल होऊन काय येईल, ओनली u of x. ओके, look at here. So y of x0 is equal to 1 upon 2 into capital U of x plus capital U of x. Okay, capital plus 1 upon 2c integration काय येईल मग x to x v of s ds. ओके, ही टर्म किती येईल, x to x म्हणल्यानंतर 0 येईल. ओके, so which is equal to 1 upon 2 right here. Okay, u of x 2 u of x म्हणजे काय येईल, हा of x and 2 to get cancel. Okay, x greater than 0. This is y of x 0. और x greater than 0, u of x कसा डिफाइन केला आहे, x greater than 0 कसा डिफाइन केला आहे, small u of x. Okay, that is y of x0 is equal to small u of x. Okay, hence equation 10 satisfies the condition number 2. Okay, now from equation 11, what is the condition number third? Condition third काय तुमच्याकडे आता, yt of x0. Put t is equal to 0 in yt. Okay, look at here. From equation 11, we have at time t is equal to 0 and x is greater than 0. So yt of x0, put t is equal to 0 in equation number 11. त्याच्यामध्ये जर 0 ठेवला काय होईल, हा 0 येईल, हा u dash of x येईल, हा u dash of x येईल. ओके, हा काय येईल v of x, हा v of x. ओके, इथे मायनस सी इंटू येईल, इथे प्लस सी इंटू येईल, हा गेट काय होईल कॅन्सल होईल, म्हणजे हा किती येईल 0 येईल, हा v of x टू v of x 2 to get cancel आणि काय हाल v of x, for x greater than 0 ला काय डिफाइन केले, small v of x. Okay, so yt of x0 is equal to 1 upon 2 into bracket minus into u dash of x plus capital C into u dash of x plus 1 upon 2 into v of x plus v of x. Okay, so this is equal to capital V of x. This is yt of x0. For x greater than 0, it defines yt of x0 is nothing but small v of x. Okay, so hence equation 10 satisfies the initial condition. Thus, equation number 10 satisfies given initial condition. Okay, any doubt? Now we have to check the given equation satisfies the equation number third and 4 and 5. Okay, काही डाउट्स असतील तर विचारू शकता. Okay, now we have to check that the equation number 10 satisfies the condition 4 and 5. Okay, what is the condition 4? Look at here. Condition number 4. Put x is equal to 0 in the given solution. Okay, and equation 5 is put x is equal to 0 in yt of xt. Now from equation 10, from equation 10 at आता t ठेवलं तर 0, आता काय ठेवायचं, x is equal to 0, put x is equal to 0. So we have y of 0t is equal to 1 upon 2. हा equation can put इथे जर मी 0 पुट केला काय येईल, हा u of minus ct plus u of ct. ओके, इथे minus ct to plus ct. ओके, okay, minus ct2 plus ct v of s ds. Okay, so here u of y of 0t is nothing but 1 upon t, 1 upon 2 into u of minus ct plus u of ct, okay, plus 1 upon 2c into integration of minus ct to plus ct v of s ds. v of s ds म्हणजे काय तुमचा, v of s हा काय, velocity. ओके, velocity v म्हणजे काय तुमचा velocity, minus ct to plus ct. ओके, इथे मायनस ct कुठेतरी असेल आणि इथे प्लस ct कुठेतरी असेल. इथे जी काही वेलॉसिटी असेल निगेटिव्ह असेल, इथे पॉझिटिव्ह असेल. ओके, दोन्हीची ऍडिशन केल्यानंतर काय होईल, हा पूर्ण व्हॅल्यू किती येईल माझी, 0 येईल वेलॉसिटी. ओके, so this term gets 0 because the integration limit is minus ct to plus ct and 1 upon 2 into, okay, what is u of minus ct is minus u of ct. Why? Because u of x is our function plus u of ct plus this one is 0. Okay, so y of 0t. Okay, so y of 0t is equal to, हे काय होईल, cancel होईल. So 0 plus 0 is 0. So initial at fixed point तुमचा deflection किती असेल, at x is equal to 0, 0. Okay, so hence equation 4 is satisfied. This is the condition number 4, boundary condition. Now we have to check the boundary condition number 5. Okay, from equation 11, now we have t is equal to, sorry, x is equal to 0. Okay, at x is equal to 0, yt of 0t Kyle is equal to equation 11. Put x is equal to 0 here. Okay, 0. U dash of minus u dash of ct, u dash of ct. Okay, okay, v of ct plus v of minus ct. Okay, from equation 11 at x is equal to 0, we get yt of 0t is equal to 1 upon 2 into bracket minus c into u dash of minus ct plus c into u dash of ct. Okay, plus 1 upon 2 into v of ct plus v of minus ct. Okay, give it in equation number 12. But we have u of x and v of x are odd functions. Okay, odd functions आहेत, म्हणजे हा ह्याची काय येईल मग, wait a minute. Odd functions from equation 8 for x is less than or equal to 0, we have what we have, capital U of x is equal to minus small u of minus x. ओके, that is u dash of x डिफरन्शिएट केल्यानंतर ह्याला काय येईल u dash of minus x. Okay, similarly u dash of ct, put x is equal to ct here. What we get? Small u dash of minus ct. Now put the value of this one is here. Also, also we have v dash of ct is equal to, wait a minute, u dash capital u dash of ct is equal to u dash of ct. So u dash of, wait a minute. So for x is less than or equal to 0, we have this one. Okay. So hence, therefore, equation 12 becomes, हा equation कसा होईल equation 12? Equation 12 becomes yt of 0t, okay, is equal to 1 upon 2 into bracket minus c into small u dash of ct plus c into, okay, u dash of ct using this condition. Okay, look at here. Minus u dash of minus ct. What is u dash of minus ct? जर मायनस ठेवला तर इथे काय होईल, हा प्लस होईल. ओके, मग हा काय स्मॉल u dash of ct. Okay, capital u dash of ct is nothing but capital u dash इथं फसले की इथं काय होईल, मग मायनस होईल. Okay, so this is u dash of ct. Okay, so this one minus c into, हा कसा येईल मग, minus c into u dash of ct plus c into u dash of ct, okay, plus 1 upon 2 into minus small v of ct plus v of ct. ओके, हा इथे सब्जेक्ट ऑड फंक्शन असल्यामुळे हा मायनस बाहेर येईल. ओके, सो दिस इज इक्वल टू, this becomes काय, हा काय येईल, मायनस प्लस 0, हा मायनस प्लस 0, so this is 0. So yt of 0t is equal to 0. Okay, this shows that the given solution is satisfies equation number 5 also. Okay, so this shows that, okay, the equation 10 also satisfies the given boundary condition. Okay, this shows that equation 10 also satisfies the given boundary condition. Also satisfies initial and boundary condition 2 to 5. Okay, so this proves that the D'Alembert solution equation 10 is the desired solution of one-dimensional wave equation. That is, we proved that the equation number 10, this equation, okay, this equation number 10 is the solution of one-dimensional wave equation of semi-infinite string. ओके, काय केलं ह्याच्यामध्ये आधी, जो वन एंड फिक्स्ड होता त्याला आपण काय केलं, कन्वर्ट मध्ये इनफायनाइट मध्ये कन्वर्ट केलं बाय डिफाइनिंग u x and v of x. Okay, redefine केला. कुठे define केला? Redefine. I u of x मी x less than 0 ला असा डिफाइन केला. v of x x less than 0 ला मी असा डिफाइन केला. ओके, साइन वेव्ह डोळ्यासमोर ठेवा म्हणजे तुम्हाला समजेल व्यवस्थित. ओके, सो दीज आर दी u of x and v of x. म्हणजे तुमची आता सेमी इन्फायनाइट स्ट्रिंग काय झाली? इन्फायनाइट स्ट्रिंग. Okay, for infinite string we have the solution u of x t is equal to by previous case. Okay, मग हा जो इक्वेशन नंबर 10 येईल, हा काय केला? हा इक्वेशन सगळे कंडिशन सॅटिस्फाय करतो की नाही हा आपण चेक केला. Okay, so here the equation number 10 satisfies all the four condition, initial condition and boundary condition. That's why this y of xt is the solution of semi infinite string. Okay, any doubt up to here? Okay, that is the solution is given by y of xt is equal to 1 upon 2 into capital U of x minus ct plus capital U of x plus ct, okay, plus 1 upon 2c into integration x minus ct to x plus ct v of s ds capital U. Okay, so this is the solution of one-dimensional wave equation for an infinite semi-infinite string. Okay, any doubt? काही doubt असतील तर विचारू शकता. Okay, in the next lecture tomorrow we will see the case number 3. What is the case 3? Vibration of a string of finite length. Vibration of a string of finite length. Okay, that is both the ends are fixed. आणि तुमची स्ट्रिंग अशी कशी होते? व्हायब्रेट होते. तुमच्या इथे दोन्ही स्ट्रिंग हे दोन्ही एंड पॉइंट कसे फिक्स्ड आहे. Okay, this part we will see tomorrow. Okay, up to here any doubt? काही डाउट असतील तर विचारू शकता.
No, sir.
Okay, wait a minute. I will take an attendance. Okay, thank you for the attending the lecture. You can leave now. Tomorrow there is a lecture on 8:30 p.m. Okay, a.m. morning 8:30. Thank you for the attending. You can leave now.